an international team of astronomers has discovered 8 of the hottest stars in the universe, all with surfaces hotter than 100,000 degrees. The discovery was made using the largest single optical telescope in the Southern Hemisphere. The data was gathered using the Southern African Large Telescope, the largest single optical telescope in the Southern Hemisphere. In a study that was done, it describes how a survey of helium-rich sub-dwarf stars led to the discovery of several very hot white dwarf and pre-white dwarf stars, the hottest of which has a surface temperature of 180,000 degrees Celsius. For comparison, the sun's surface is a mere 5,800 degrees. One of the stars identified is the central star of a newly discovered planetary nebula. To discuss this, we're being joined by Dr. Daniel Cunnama, Science Engagement Astronomer, South African Astronomical Observatory. Good evening, Dr. Cunnama. Thank you very much for joining us. Quite a lot of science language here, but there is a new discovery. Kindly break it down on what you and your team discovered in simpler terms.
Good evening. Thanks for having me on. Yeah, so basically what we do, one of the many things we do at the observatory and astronomers in general, is survey stars. So the stars that you see in the night sky, and there are millions and millions more, are all different. The same as people, they come in different colors, different sizes, different temperatures, and we like to survey them. From that, we can understand better what they are, how they evolve, and what the population of stars within our galaxy or within a region looks like. So this survey was, as you said, looking at helium-rich subdwarfs, so a certain type of star. We were using the Southern African Large Telescope, SALT, which is based here in South Africa, to study these stars and document them, take spectra of them, so looking at their light and breaking it up into all its different wavelengths. And from that we can measure its temperature and many other things about it. And we can learn a little bit about this section of the population of stars. And in doing that, we can start piecing together, the entire population and how stars form and evolve.
Okay, we understand some of the stars discovered are at an advanced stage of their life cycle and approaching the end of their lives as white dwarfs. Please, what are dwarfs in the first instance, and then explain a little more what this means.
Yeah, so stars, they have a life cycle, so they form out of condensed gas, mostly hydrogen and helium. That forms together and it ignites fusion, and then they burn for millions or billions of years. Our sun, for example, is 5 billion years old. It's been burning for that long, and it'll burn for another 5 billion. And each star has its own unique life cycle. So some will live a long time, some will live a short time, and that's dependent on their mass, what they're made of. And these white dwarfs are stars at the very end of their life. So when the star runs out of fuel, it runs out of its hydrogen or helium to ignite fusion, it starts to change. It'll blow up into a red giant, for example, or in some cases it'll shrink down to become a white dwarf. And that means that a white dwarf it's something like the mass of our sun, but it's compressed into a very small area. So something the size of our Earth, but with the same amount of mass as the sun. So it's a very, very dense object, and that's why these things can get so hot. And then there are many of these out there, from stars which have died, and then slowly they'll evolve further from there.
I'm sure a lot of persons are as curious as I am. Of what help are these discoveries to us? I mean, the significance or what it means to the evolution and the analysis of the atmosphere around us.
Yeah, so we really want to understand what the universe around us is made of. We want to know where the planet came from, where other planets may form, where life may have formed. And in order to know all of that, we need to understand, how stars are forming, how different stars like our sun have formed, and then how do the planets form around them. We really need to understand the entire picture of our universe if we're going to have any sort of firm understanding on where we came from. And then obviously within that, there's a whole lot else we learn. I mean, we have to push the technological barriers beyond anything where we've tested them before, and then try and look for new physics, or if we find something we don't understand, we have to really explore that, and we never really know what we're going to find, and that's kind of why astronomy is such an exciting field.
Indeed, your team and yourself, you all have your work cut out for you. We wish you all the best, and we look forward to more discoveries from you. Thank you for joining us.
Thank you very much for having me.